Welcome to my YouTube channel. I hope you are fine. So, in the last lecture, we discussed about the four types of sampling, right? One is the systematic sampling, cluster sampling, and we also discussed about systematic cluster sampling, then we stratified sampling and random sampling. So, these are the samplings that we discussed comes under the probabilistic sampling comes under the probabilistic sampling. So, what are the probabilistic sampling? Probabilistic sampling means these are the samplings that come based upon the probability of occurrence. Probabilistic samplings. This comes under probability samplings. So what does this mean? Based like here the concept of probability plays a very important role. Like let's say here you are doing random sampling. So in the random sampling, what example I gave? Let's say if this is your particular six populations you have. Let's say this is your populations, and out of this you are doing the random samples. Let's say here you are selecting this particular thing and this, let's say these three you are selecting. So these three are nothing but the elements that you are selecting, correct? So now out of these three, if you observe or not, the probability of occurrence of this element, like probability of getting this element, will be 1 by 6. Similarly, the probability of getting this element is 1 by 6. Probability of this element will be 1 by 6. So means what? Here the concept of probability is playing a very important role. That's why this type of sampling where probability is crucial. That type of sampling is called as probabilistic sampling. And random sample is one of the example for this. Now let's say in stratified sampling, what we have done, we have first taken the population. Let's say this is the population where we have taken the, let's say this 3, 4, 5, 6 we have taken, and out of these 6 what we have done, we have to create the samples. So how we create the samples? Based upon the groups we'll create the samples. Let's say this is one of the group, this is one of the group, and here this say, if let's say this is one of the group, these are the two groups, correct? So now let's say if we have selected this red particular group, and in this red group we will use the, like in this red group we will do the random sampling, correct? In this, let's say if we are selecting the red group, in this we will do the random sampling. So now in this, let's say if this is your element, this particular center, let's say we are selecting this particular element, so the probability of getting this element will be 1 by 3, correct? Because 1 is your first element and 3 is the total, so 1 by 3 probability of occurrence. If you are selecting two elements, let's say these two are selecting elements, the probability of getting these two elements at a moment will be 2 by 3, correct? So probability of collecting two occurrences, creating two random samples inside a group, there you will get the value as 2 by 3. So here the concept of probability is using. In systematic sampling also, probability sampling is using. How? Now let's say if this is the particular circle, you are having 6 entries, 1, 2, 3, 4. Let's say we're having 8 entries, let's say. So in systematic sampling, what we have done, we have taken the, here let's say this is the population, and let's say this is the sample. Okay, so here what has happened here, let's say I selected two elements, means these are the two elements that you will get here. So now if in populations, in systematic sampling, what happened depending upon the k value. Let's say if we have selected the k is equal to 3, and now here you see the, here first element you have to choose, right? The probability of choosing this as the first element, probability of choosing this as the first element will be how much? 1 by 8. Why 1 by 8? Because this number divided by total number 1, 2, 3, 4, 5, 6, 7, 8. So 1 by 8 is the probability. So now after selecting this as the number, then you have to put k is equal to 3. Let's say we are going in this particular direction, let's say. So 1, 2, 3, this is the k. The probability of getting this value will be 1 by 8. Will be 1 by 8. And probability of getting this value is also 1 by 8. So here also the concept of probability is been using. In the cluster sampling also the probability is using. How? Let's say I am taking this as the circle. Here we'll take 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. So now here in clustering, what we will do, we will first group this particular thing. Let's say if this is the one group, then this green will be the second group. Based upon the similarities, based upon this all the factors, we will select it into groups. Now, probability of selecting this particular group, let's say if this is the sample, let's say now let's probability of selecting this particular group will be 1 by 3 because total 3 groups are there. So probability of selecting this group is 1 by 3. The probability of selecting this group will be 1 by 3. Let's say if you are selecting two groups, then your probability will be 2 by 3. So here also if you observe, let's say here we are selecting this brown group, so this will come like this. So now from this what you understood in this all of these four concepts, the concept of probability plays a very important role. So that's why this type of sampling is called as probabilistic samplings. Now the next topic comes is the non-probabilistic samplings. This non-probabilistic samplings is important for you guys to know, like what are the types of samplings that you have. Two types of samplings you have: probabilistic, non-probabilistic. So what are these non-probabilistic samplings? Here we won't be using the concept of, here no concept of probability is used. Here there is no need of probability, no need of probability. Okay, no need of probability here. So what are the things that we're going to study here is, we'll study what is the non-probabilistic sampling definition, we'll study the types, we will study the characteristics, and we will do the quick comparison. These are the four things that we're going to study. Now what is the definition of uh, this non-probabilistic sampling? Now I will take one example. Let's say, now let's say here I want to take for example, what example I will take, let's say I am traveling on a road. Okay, I'm traveling on a road to conduct the survey. So what I will do, I will select some random people. I will select some random people and I will take the survey, like which movie is good. Let's say like many people does not like, they first day first show ticket, they will go to many reviewers go to the theater and they will ask the review, where they will select the random people and they will ask. So here what is happening, here there is concept of probability is not there, and everybody are getting the equal chance. That is the very important. So here everybody are getting the equal chance, and here there is no concept of probability. When we see in probability, what happens here, out of these six people you are selecting one people, but here we are selecting random people in random area. So that type of sampling where there is no need of uh, probability is called as the random sampling, non probabilistic sampling. So it's a sampling technique where not every individual in the population has a known or equal chance of being selected. Means what here? Here like here nobody, there is, you cannot predict like I will get chance or not. Depend, like if I want to take some decision, I will take randomly. I won't see like what happens if this happens, what is this. So the probability I won't be going to take. So it is often used when the random sampling is difficult. See, random sampling is difficult because for 9 data you are selecting random is okay. But if you are having 1 lakh data, 1 lakh of data, in that you have to do random, then how will you do the random? And the condition is you don't have this exact 100 data. How will you do it? So to do that, we will be using the non probabilistic sampling. So now here in the key point here is, this selection is based on the judgment, convenience or referral, not on randomization. So like many people who get the job without interview, without this, so the probability of person getting hired for this job, the probability of getting he cracked in the interview is not here. He directly got the job. That is the point here. Like through someone he got the job. Is there any probability involved here? No. That's why this that is what the non-probability concept. One simple example. So let's say if you are searching for a job, let's say. So to search a job, what will happen? You have to apply the job. Let's say if 1,000 students have applied, let's say for this job, Then your resume shortlist will happen. Resume shortlist will happen. Shortlist will happen. Let's say out of this 1000, let's say 200 resumes got shortlisted. Then they will conduct some exam, and out of this exam, let's say they selected 100 people, let's say, and out of the exam, then they will conduct the interview. For interview, they will conduct, let's say, 20 people. They'll conduct the interview, and they will give the job for, let's say, two people. Let's say two people. So here you see the probability of your you applying the job is 1000, correct? So the probability of you applying the job means how much will be 1 by 1000. Then resume, let's say if your resume got shortlisted. So what is the probability of your resume got shortlisted will be 1 upon 200. So here if you see that the concept of probability is there here. But if you say like you got the job directly, like through the help of referral, you got the job. You got the job. So now you got the job. So is there any probability involved here? No. But the problem with this non-probabilistic approach is sometimes they, like let's say you are getting a job, let's say for AML engineer you are getting the job, correct? So to get AML job engineer, I directly got the reference. Let's say I am searching for the job and I got the referral. So like let's say if I am not that good at AML and I got that job, will I able to perform well? No. Compared to the person who knows AML, I cannot perform well. So that's why your accuracy will be compromised in this thing. So accuracy will be compromised. So this is why your non-probabilistic sampling sometimes is not that accurate. So there are types of non-probabilistic sampling. One is the convenience sampling, judgmental sampling, snowball sampling, and quota sampling. These are the four things that you are having. Very simple, these four are. I will explain this in, let's say, how much time? 12 minutes I've done. No? 2 minutes I'll explain this concept. Very simple. Convenience sampling means one very simple example I'll give. Now let's say you want to take this survey of a film, survey of a movie, survey of movie. So to take the survey of movie, what you will do, you'll directly go to theater, outside the theater, and you will take this survey from people. The benefit of this is you will get very quick response will get from people. They'll tell, okay, the movie is hit, the movie is worst, flop, the movie is worst. The people will tell it. So the benefit of this is you will get the fast reply. Very fast you will get. But the accuracy is But the problem here is it has high bias. The results may not represent the population. Means what? The person has told that this movie is flop. From this, can you make an insight out of it? You cannot make an insight. Maybe for that person, movie is not good, but for other person, movie might be good. So you are not getting the accurate results. That's why you are convenient sampling to get accurate results. You won't be using the convenient sampling. The second example is judgmental, like purposive sampling. So purposive sampling means what? Let's say, uh, let's say I will take one example. Let's say you want that you want to, let's say, take a person who got, let's say, diabetes. Let's say you are a doctor and you want to study about the case of diabetes. So how will a doctor able to study about the case of diabetes? He will fetch the individuals who got the same problem. Okay, he'll fetch the individuals. He'll fetch the individuals. So now the problem with fetching individuals is he will understand, he will take all the symptoms, like what are the symptoms, like he got some he's getting more urine, or he's getting tired easily, he's unable to do work properly, he's sleeping more. Like this he will take some information, he will take. But the problem here is, from the patient, will doctor get any information about the disease? No, because here the doctor himself have to research on it. He just get the insight from the patient. But will it be useful in giving him the medicine? Will it be useful? He is studying for the first time. In first attempt, can he able to give medicine for diabetes? He cannot give. So that's why what you will do, researchers select the individuals based on knowledge or judgment. So here doctor what he is doing is selecting the patient based upon the symptoms. Let's say choosing industry expert to survey about a new technology. But here the advantage is he will get the all the needful information the doctor will get, but he cannot able to generate medicine because he's studying for the first time. Unless and until he get the mentorship from the senior doctor, he cannot give the medicine. This is the con of this particular thing. So he will select some random person who got the diabetes. So the random person, you don't have the count, you don't have like out of 100 you have to select, you don't have this count. You will select some random person who have this diabetes. So from one case you cannot able to detect the medicine. That is the thing. This is nothing but a judgmental sampling. The third type of sampling is snowball sampling. Now, what is this snowball sampling? Here in snowball sampling, the job example I gave now, that referring thing, it comes under snowball sampling. Let's say you are having a job. You are having a job. So for job, you what will do? You'll apply the job. After applying the job, you will get an exam or interview link. After exam, you will get an interview. You'll get an interview. Like this you will happen here. You don't know how many people have applied, how many of them gave exam, how many of them gave interview, and how many of them got selected in the company. You don't have this data. So you just randomly apply in the companies, and you gave the exam, you give the interview, and out of this you got selected. So if you get selected like this, obviously the talent will be more. But here in this snowball sampling, what will happen, you will get the job by using the referral. You got the job. So now this, the problem with the referral is, if I don't have the knowledge that this selected candidate have, let's say if the person who got selected, that knowledge I don't have, then will I able to do the job efficiently? No. That's why in this snowball sampling, what will happen, existing participant refer the new participant. So from the organization, he is referring me, is the best example. Surveying people with rare disease, each participant refers others they know. So in companies also, if they want to hire someone, what it will do, it will tell their managers or general managers to refer some of the candidates for us so that they can contribute in our organization. But you cannot know that that person has full skill or not, that you don't know. It helps in accessing hard to reach the population, like to doing this, conducting this all steps, you can able to, like you can stop all of these steps and just take the referral help. This is the pro con. But the con means what, can introduce a network bias, means sometimes the selected candidate who got referred might not have the knowledge on it. This is called as snowball sampling. Fourth is what, quota sampling. So quota sampling means what? I will take one very simple example. Let's say I want to take survey of a particular product. Survey of a particular product. So to take this survey of product, what I have to do? I want that I should take survey of 60% for male and 40% for female. Okay, I want to do this kind of survey, female. So I will take survey till my conditions meet. I will only take conditions till my conditions meet. Okay. And you here you will do, you will find 50-60% of male people near you. You will take you will take the, what I can say, you will take the survey. Similarly 40% female near to you, you will take the survey. So but here the advantage is, like here guarantee representation of key groups, means you will able to achieve this 60% male and 40% female, you will going to achieve. But the con is what, selection within the group may be biased. Means what, let's say if out of the 60% male, if someone from this particular product company, if some person is there, he will obviously tell the product is good or not. Similarly, if one female is there who is working in this company of this product, then she will directly tell that the product is very excellent. So the results that they will tell may be biased. So that's why this quota sampling is also not that useful. So these are the four type of samplings that we have. Convenient means what, randomly you are going to theater and you are asking this, you are taking this survey. but you won't get the accurate results. Second is more judgmental. Doctor finding one diabetes patient, taking information is okay, but can he generate the medicine? No, because he only took information of one person and he studied only for one person. Like this, you have to study them for 1,000 person. They have to study. Now, snowball sampling means what? Let's say you are applying a job, you have to do all of this process. But in snowball sampling, what will happen? Instead of doing all of this process, you will just use the referral policy. You will use. So in fourth, what happened in quota sampling? Let's say you launched a particular product and you want to take the survey. So let's say if someone is working in my company who is doing this product, can he able to say something bad about my product? He cannot say. So this is why you are a four type of non-probabilistic samplings. These are some of the challenges we have. So what are the key characteristics of non-probabilistic samplings? Now doesn't rely on randomness. So means what? Whatever you see someone, you will take this thing. There is no like you have to go to this particular area, then you have to do random sampling. Not there. This is one of the advantage. It is very cheaper, faster than probabilistic sampling. Obviously, like you randomly are taking the survey, so this is easier now. Like instead of fetching for 500 people out of India and then taking survey, it's a cost, it's a time consuming process. So we won't be using this approach. Third thing is what? Cannot calculate the sampling error or make precision inference about the population. It cannot, but the drawback for this is it cannot able to find the exact error. People might be biased, and it is useful for exploratory research, for research purposes, to study more about the particular diseases. You can use the non-probabilistic sampling. So if you see the compareness, like probabilistic sampling versus non-probabilistic sampling, the chances of selection, like 500 out of 500, you have to select a person, so equal chance you are giving. Here there is, you will doing random selection, you are doing here bias, the biasness will be low. Like you are selecting top 400 people who are having the AI knowledge, so they can able to contribute in your organization. But here in non-probabilistic sampling, you are randomly selecting some person and you are referring the job, so here the biasness will happen. Generalizability means what? Here the data can be generated in very high ways, here in the low ways. Example means what? Simple random stratified. So where was I? Yeah, I was telling this example. Simple, random, stratified, and here we have conventional, purposive, snowball. These are some of the types of examples that you have. So that's it, guys. I hope you understood the concept of non-probabilistic sampling. So from next lecture onwards, we'll going to deal with the measures of central tendency. So that's it, guys. Please do like, share, and subscribe, guys. So thank you, guys.